About 500 years before the Common Era, there was a man in ancient Greece named Pythagoras. And Pythagoras did some amazing things with numbers. You probably know his name because of the Pythagorean theorem. But this has to do with something else. This has to do with factoring. Let me get it started. Okay, what Pythagoras said was that if we add all of the factors, and what's a factor? A factor is a number, a divisor, such that if you divide it into a number, a given number, like let's say you divide 2 into 12, it comes out evenly. In other words, there's no remainder. And so 2 and 3 and 4 and 6 are all factors of 12. Okay, so what did he say? He said if we add all of the factors of a number together so that they give us a new number in the sum, and then we add all of the factors of that new number together and get another number, and we continue doing this, getting new numbers each time and factoring each time, we will eventually come to just one factor, the number 1. In other words, we will come to a prime number. A prime number that is a number that has no other factor besides 1 and itself, although we're not going to consider the itself part, just the number 1. Now, sometimes the sums get bigger, and sometimes they get smaller, and sometimes the sums equal the original starting number. So that would mean that it would just go into an infinite loop, and I have discovered one. But it's not in this first video. There are going to be 2 short videos, so let's just do this. The first starting number we got was 5143, which was chosen at random between the number 1000 and the number 10,000. So it came up with 5143, which has 3 factors. The total of the factors is 177. And I'm just going to keep going. Okay, so what this program does is it refreshes the start number by adding the 3 factors from the previous number. So, okay, now the original starting number was 5143, okay? And so far we've found factors and added them together just one time. So 1 run so far. Here's a second run. Here's a third run. Whoop, and on the third run, we found a prime number, 41. Okay, so it just took us 3 runs to get a prime, and that's the way Pythagoras said we will always eventually end up, no matter how many dozens of runs we have to take. So let me just run it a couple of times so that you can, let me get out here. And just so you see how it works, okay, whoops, prime the very first time. Okay, here we go. All right, so, okay, this time it got a prime after 2, 829, but I want to do it so it runs just a few. Okay, here we go. 4 runs, 5 runs, 6 runs, 7 runs, 8 runs, 9, and it took 9 runs to find a prime, which is number 43. Now, I'm going to stop this, and I'm going to make a whole new video, which I'll add to this one, because I have discovered something truly amazing. I'll be right back. Okay, I am back. This is a whole new program, but it's based on exactly the same principle as before. Earlier, I had only 50 factors. Now I have 90 factors, okay? And the reason I have 90 factors, let's get it started, is that I have discovered a number that goes in an infinite loop, okay? All right, so watch. I had to redesign the page in order to make room for all of the factors, and we've just run it twice now, and remember what's happening. The sum of all the factors for this number, and there are 10, 11, 12, 13, 14, there are 15 of them. Okay, yeah, right there, 15 factors. And the sum of all those factors is there, and that'll become the next number, okay? And that 83,328 will become the next number. So that's the process, okay? This time got 63 factors. How about that? My previous program couldn't even handle that. Now, this time we got 83 factors, and we've only run it 6 runs so far. Okay? Now I'm going to go rather fast because I don't want to take all night with this, but here we go. You understand the process. Each time it adds the factors together, and that sum of those factors, it becomes the next number. Okay, so 48,976 will become the next number to be factored. The sum of those factors becomes the next number. 22 runs so far. Now watch what happens, because when we get right about here, no, not quite, boom. Look what just happened. What happened was the number 17,716 had 11 factors that total our original starting number. And what does that mean? Well, that means that we're going to have the whole thing all over again, and we will run it 26 times. So now we've added 26 times to the previous, and it's come right back to 14,316. Now, what do you think Pythagoras would have thought of that? And thank you for watching.